In part one, we talked about how little overpressure you need internally to lift up a tank. How the internal overpressure to lift off a tank that can weigh 500,000 kilograms can be as low as 0.05 bar. We said that the floor needs to shear off before this tank liftoff occurs. And indeed, that's what happens in all of these cases. We also said that if the roof doesn't break open, that there are stress concentrations on the perimeter of the floor that cause it to shear off. But there's more to this. How does the floor shear off for a tank at internal pressures well below the pressure rating for explosions? How do some structures collapse at internal pressures well below their pressure ratings for explosions? Here's how. This pressure for tanks like this and for certain other buildings acts for a very long time. And when a pressure acts for a very long time, the building will fail at a much lower pressure than what it's rated at. You don't have to actually reach the overpressure threshold of the structure if the time during which this overpressure acts is very, very long. In other words, let's say you have a building that can withstand 0.27 bar. But instead of 0.27 bar, let's say you have an overpressure of just 0.11 bar acting on this building. But the overpressure acts for 5 seconds or even longer, 50 seconds. If that happens, you've got 1,000 times more duration and 1,000 times more impulse, because the impulse is just basically the area under the curve, and the longer the overpressure acts, the higher the impulse. You've got 1,000 times more than you normally would. That will cause the structure to collapse. And a good way to look at this is the PI curves, such as you can see in design of blast-resistant buildings in petrochemical facilities. Here, the x-axis is the impulse for this PI curve, and the y-axis is overpressure. You could see along the line of constant damage the collapse overpressure at an impulse just greater than 100 psi milliseconds. That collapse overpressure is about 10 psi. But if you increase the impulse to 200 psi milliseconds, that collapse overpressure drops by a factor of 3. And the reason why tanks like this or buildings like this have sustained overpressures that act on them is, in fact, that there's very little venting. So if the roof doesn't flange and you've got very little openings, a small manhole, it's a big, massive tank, or a building that's just completely sealed, no windows, no vents, then you're going to get an overpressure that acts on the walls for a very, very long time. exploCFD version 10 not only shows you the overpressure time history and spatial distribution, it also allows you to calculate the impulse that's delivered to structures. And the installation folder of the software also includes a PI curve generator, a pressure impulse curve generator. And this allows you to input the wall dimensions, a reinforced concrete panel dimension, such as thickness, width, and the length of this panel, and it will quickly give you a rough estimate of failure, overpressures, and impulses. So you just load in the dimensions, you hit Alt F8 and run the macro, and you could see that typically the wall panel for this case will fail at, say, 160 milliseconds with an overpressure of 30 kilopascals. That's quite typical for a reinforced concrete wall. But what a lot of people don't realize is that this same panel could also fail at much lower overpressures, but with much higher durations, because the impulse, which is really what causes the damage to the structure, is still so high for this case. So in this case, we have a pressure of 10 kilopascals with a duration of 5,000 milliseconds, and that's causing failure of the panel, even though 10 kilopascals is much less than the rating of 30 kilopascals. We just had a case like this, where the overpressure of a concrete wall was about 30 kilopascals, and that's the onset of failure. And typically, this 30 kilopascals will be applied for a duration of 100 to 200 milliseconds. But because of the design of the whole structure, the whole building, we saw a case where 10 kilopascals of overpressure was delivered to the panel over a period of 5 seconds. And that was at least 5 seconds. It could have gone on for more, but the simulations showed 5 seconds. So that's 5,000, not 160 milliseconds. The high impulse can be delivered with a pressure that's significantly lower than the rating of a wall, and this often ends up with catastrophic failure of the structure. Anybody can press a button and generate data, but do you have the right tools and the experience to draw the right conclusion from this data? That's what exploCFD version 10 offers.